Myself is Ilika Mitra of Netaji Subhash Engineering College, Kolkata. I am studying ECE in first year. I will talk to you today regarding sensors and actuators. Now, what are sensors and actuators? Both of these are types of transducers which converts one form of energy to another. In the case of sensors, it converts the physical parameter into a signal which can be measured electrically. Whereas in case of actuators, it converts the electrical signal into physically perceived output like motion. Today's topic will be based and analyzed upon these subtopics for you to understand categorically and grasp the matter easily. I will further brief you about the core of hardware, sensors and actuators, hoping that you would find the session interesting and informative. So firstly we will come to know about sensors and its classification. Then we will discuss some important terms associated with the sensors which you may encounter frequently while working with them. Followed by this, there will be a display of some sensors and their practical application. Our discussion will be continued as we will talk about actuators and their classification. Finally, we will talk about some motors. A sensor is a device or a module, machine or subsystem where purpose is to detect events or changes in the environment and send the information to the electronics, frequently computer or a microprocessor. Here the detection of an event can be well understood by the change in physical parameter. The information conveyed to the electronic device is the electrical impulse generated by the sensors. The type of classification of the sensors can be based upon input and output of the sensor. When we base upon the input, the sensors can be of two types, active and passive. The active sensors are the sensors that produce the output signal with the help of an external excitation supply of voltage or current. The own physical properties of the sensors varies with respect to the applied external effect. Therefore, it is also known as a self-generating sensor. Example, IR sensors, ultrasonic sensors, and all the other sensors that we will discuss later. Passive sensors are the types of sensors that produce the output signal without the help of the external excitation supply. They do not need any stimulus or voltage. Example, thermocouple which generate a voltage value corresponding to the heat applied. It does not require any input. The output-based classification of the sensors are of two types, digital sensors and analog sensors. Analog sensors produce a continuous output signal or voltage which is generally proportional to the physical quantity being measured. The output values of analog sensors can be of 0 to 255. Example of accelerometer, temperature sensor and pressure sensor. Now coming to digital sensors or electronic sensors in which the data transmission to other electronic devices takes place digitally. They produce an output of either 0 or 1, that is low or high. Examples are PIR sensor, and IR sensors. Now we will see some important terminology related to sensors. Firstly, datasheet. Datasheet is a document that summarizes the performance and other characteristics of a sensor. This gives precise information about the input and the connectivity protocols with the microcontroller. Now, coming to errors. As we all know from the school days that error is the algebraic difference between the value indicated by the sensor and the actual measured value of the variable. Errors may be caused due to following reasons. Firstly, zero error, where the errors is due to not having a proper zero reference. Secondly, the errors occur due to the change in operating range of the process. Lastly, the errors may also occur due to the mechanical wear and tear of the sensors over the time. Errors are not desired. Hence, we move on to our next point of ponderance. It's calibration. Calibration is the adjustment or a set of adjustment performed to the sensor or instrument to make that as accurately or error-free as possible. Next, we come to the range of the sensor. The range of a sensor, as the name suggests, true is the minimum and maximum value of the concerned parameter that can be measured by the particular sensor. To the next topic, that is response time. As the name suggests, the time taken by the sensor to respond or react to a given input is the response time. Lastly, yet not the least, the cost and lifetime of the sensor. The cost effectiveness and the longevity of the sensor should be dealt upon before selecting a sensor for your particular project. Now let us see some practical examples of sensors. Light dependent resistance or LDR is a type of photoresistor. It is a passive component that decreases the resistance with respect to receiving light or component's sensitive surface. The graph on the left side of, of the slide depicts the relationship between the resistance and the light intensity. The relationship is simply the inverse of each other. The working principle of LDR is photoconductivity. When light is absorbed by the active material as shown in the figure, the valence electron get excited and move to the conduction band, provided the photons have the enough energy more than the band gap between the valence shell and the conductance band. From the conducting band, of the active layer, the electrons are transferred to the metal contact, hence reducing the resistance and increasing the conductivity. The illustration in the center shows the picture of an LDR. Even though we are discussing a basic sensor, we can make very impressive and cool stuff like a laser piano, as shown in the background. Here, the basic sensor used is an LDR, which measures the intensity of the laser beam and plays the corresponding music note appropriately. Automated street light systems to work on this principle so that as the sun sets, it switches the light on, and after the sunrise, it switches the lights off. We can also implement this in our homes. IR sensors or infrared sensors. IR or infrared light is an electromagnetic radiation with wavelengths longer than those of visible range of light. Infrared sensors, as shown in the picture, contains one photodiode, which is black in color, and the transparent LED, which emits infrared light waves. Hence, here the LED works as a transmitter, TX, and the photodiode acts as a receiver, RX, of infrared lights. The working principle of an IR sensor is based on the reflection by objects. Whenever the infrared ray is reflected by the obstruction and received by the receiver, a voltage level is generated across the terminal. This voltage level depends upon the intensity of the infrared lights received. Now the voltage level creates the electrical impulse, which in turn is communicated to the microprocessor or the computer processor. We know that the darker colors absorb light best and reflect the minimum amount of light. So the receiver of the light less than the detectable range, whereas in case of brighter surface, the reflection of light is more than the detectable range. Hence, we can distinctively differentiate the darker and brighter surface, depending upon the amount of light received with the help of the IR sensors. The range of IR sensor may vary from 10 to 50 centimeters. However, for high-end and expensive products, the range may vary from 1000 to 5000 millimeter or 1000 or 100 to 500 centimeter. We can see the blue box on the sensor in the illustration. This box is a potentiometer, which helps in calibration of the sensor. We can also notice that the sensor has 3 pins, namely the VCC, where the 5-volt input voltage is given, ground, that is basically the cathode connected to the LED, and the photodiode. Lastly, the output pin. The infrared sensor can be used both as analog and digital output sensors. Now coming to the use cases of an infrared sensor. The infrared sensor can be used to make autonomous robots like line follower robot and obstruction avoidance robot. We can construct a line follower robot with a 2 or more IR modules. For further interesting details and hands-on experience of building an autonomous robot by yourself, follow the bootcamp closely. You can learn how the sensors sense and the actuators move on the basis of the sensor's input by the microcontroller to determine the direction on its own. IR sensors can be used for making automated indoor lights. It cannot be used to make the street automation lights, as the rays coming from the sunlight may damage the sensor and may produce erroneous output. Now we will consider a new type of sensor based on the principle of sound waves. These are ultrasonic sensors. The working principle of this module is based on the reflection of sound waves. It emits ultrasonic sound with a frequency of 40,000 Hz. Like all the sound waves, it also travels at a speed of 433 sorry, it's 343 meters per second. On the left hand side, where it is marked T, it is the transmitter, where where the sensor transmits the ultrasonic waves from it. The right hand side, marked with R, is the receiver portion, where the reflected waves are received. In the right corner, the diagram depicts the emitted sound waves in red color and the reflected sound waves in green color. This phenomenon of detecting sound waves is also seen in bats. They do not have eyes. However, by emitting the ultrasonic sounds, they can sense the environment and obstruction present nearby. Using the same principle, we can find the distance of the obstruction from the sensor. Now, as we know, the speed of the sound waves is 343 meters per second. So, we can easily calculate the distance from the equation. Velocity is equal to the distance per unit time. Here, the time is the time lapse or the time gap between the transmitted sound waves and the received sound waves. This time lapse contains the time taken by the sound waves transmitted by the sensor to reach the obstruction and the reflected waves to reach the receiver end of the sensor. Since the total time taken is twice the actual time required by the ultrasonic sound waves to travel from the sensor to the obstruction, hereby multiplying the total distance by half or 0.5. Hence, the working formula is given on the slide itself, where it tells us the distance is equal to the factor half or 0.5 multiplied by the velocity of the sound wave, that is 343 meters per second, multiplied by the time. As we can see the pin layout of the sensor showing us 4 pins, namely VCC and ground, where the low and high voltage is supplied. Low voltage to the ground and high voltage to the VCC. Trigger pin or trick pin, which is connected to the transmitter portion and is responsible for ultrasonic wave transmission. When trigger pin is set to high, that means the trigger or transmission of the ultrasonic waves echo pin is connected to the receiver that receives the echoing part of the reflected sound waves by the obstruction. Now, moving on to the use cases and application of ultrasonic sensor in robotics. An ultrasonic sensor can be used in several DIY projects. We can make a distance finder from the sensor. It uses the equation given in the previous slide to determine the distance of the obstruction from the sensor. The distance measured can be as long as 250 cm with an accuracy of 3 to 4 mm. We can use this distance finder in several other projects like water level finder or the height finder, etc. That depends completely upon the creativity of the maker. Radar. Now, radar is an instrument which is used for detecting, locating, and tracking of objects of various kinds at a considerable distance. However, the original radar, though uses the same principle but using radio frequency waves, we can create a radar with the help of ultrasonic sensor. Smart garbage bucket. It senses the person coming closer to the bucket so that the person is able to put the garbage in the bucket so as the name suggests, smart garbage bucket. It senses the person coming closer to the bucket so that the person is able to put the garbage in the bucket without the contact or touch. Hence, it opens the lid automatically as, as it senses the person coming nearer to it using an ultrasonic sensor. You can also implement this concept to a hand sanitizer dispenser to work on a touchless mode. This concept can be taken to much use in the present pandemic situation. Finally, I will tell you about the autonomous robot, which can sense any obstruction in front of it and suitably accommodate to avoid any head-on collision. This is a collision avoidance robot or a obstruction avoidance robot. This uses a ultrasonic sensor, finds the distance, and hence, according to the sensor input, the microcontroller decides how to rotate the actuators in which direction and other details. For further details, stay with the stay with us in further bootcamps and do subscribe the channel so that you can be a part of GNX NSC. Now coming to the next sensor, gyroscope and accelerometer. The gyroscope is a device used for measuring and maintaining the orientation and angular velocity. The accelerometer is a tool that measures proper acceleration. All measurement of these devices are in three dimensions. As we can see in the diagram on the right side, the gravitational force mg is shown along the component acting along the orientation and the bomb and perpendicular to it. From the force along the orientation, we can get the orientation or theta if we know the mass of the body, as the g is already a constant value, that is 9.81 meters per second square. Just like this, a ball of known mass is there inside the sensor, which helps us to get the orientation of it. From the orientation, we can get the angular velocity and hence the acceleration. Now, in the diagram, it depicts the case only in 2 dimensions, but in reality, it works in 3 dimensions. The pin layout of this sensor is a bit complicated one. It contains 8 pins in total. The VCC and ground is common to all the sensors, which are the 5-volt input and the ground of the system. The interrupt pin is to indicate the data is available in the sensor and hence the communication between the sensor and the microcontroller begins. The SCL and SDA pins are serial data and serial clock pins, which are used for I2C communication between the microcontroller and the sensor. And XDA and XCL pins are the serial data and serial clock pins. Of these pins and a live demonstration of the module along with practical application of the sensor do follow the further bootcamps. Now the practical implementation of this sensor can be used in with a manually controlled. The example of autonomous robot using this sensor is a self-balancing robot. As you can see in the illustration, this also has an ultrasonic sensor to avoid any obstruction. This basically maintains the orientation with the controlled movement of the motor. This particular example can be also of one-wheel car. In the illustration, it's given two-wheeled car, but you can also try to make one-wheeled robo which can be controlled via wireless protocol such as Bluetooth, Wi-Fi, Zigbee, and the like. Next, we come to the example of the manual robot, that is the gesture controlled car. This robot is basically responds to the feedback of the movement of the sensor. The sensor you can also put in a gloves so that the movement of the gloves is sensed by the car and it moves according to the movement of your hand. Now coming to the next portion of our discussion, that is actuators. An actuator is a component of a machine that is responsible for moving and controlling mechanism or system. In simple terms, it is the mover. An actuator requires control signals and a source of energy. The control signal is sent via the microcontroller based upon the sensor inputs. An actuator acts as a transducer, converting the electrical energy from the source to a mechanical one. An actuator can be classified based on input and output modes. The input-based classification gives us two types of motors, namely rotary and linear. As the name suggests, rotary motors gives us the output of an angular motion, that is, motion in a circle. The linear motors, on the other hand, gives us the straight line motion or linear motion. Both of them are used widely in robotics. For their practical implementation in the real life and in robotics, and the demonstration of each of them, take a look to the further bootcamps. Coming to the input-based classification, the typical sources of energy in actuators are electrical, hydraulic, and pneumatic. Pneumatic. The electrical motors used the electrical energy for their movement. It's broadly used among all types of actuator. The hydraulic motors use the variety of liquids and the pressure generated due to the flow of it. The pneumatic motors, on the other hand, use the source of energy as the air pressure or the compressed air. Now we will discuss about different types of motors in the field of robotics, namely DC motors, brushless motors, servo motors, and stepper motors. We would try to give a live demonstration about them in further bootcamps. Continuing the discussion, the name, as the name suggests, DC motor works on the direct current or DC current. Hence, it converts the DC input electrical energy into mechanical energy. As most basic level, DC motors work well in robotics because they allow the robot to be driven by a battery. This hereby offers a great advantage as it can be powered easily available and cost-effective simple batteries. And the batteries also make them wireless. DC motors can be of use to locomote the wheels of a robot. They can be classified into two types, namely center shaft and side shaft. The shaft of a motor is a mechanical component for transmitting the torque and rotation. It extrudes out of the motor where the wheels can be attached via screws. The center shaft motors, as the name suggests, extrude out of the motor centrally. Side shaft motors, as shown on the right hand side, as the name suggests, the shaft is shifted to one of the sides so as to generate more torque and ground clearance. This motor is commonly preferred in heavy duty cars where the movement is over rugged terrain. Now coming to the most interesting part of the actuator section, a brushless DC motor. The illustration shows a brushless DC motor along with a electronic speed controller ESC, which is here shown in yellow color. It is one of the high speed motors available in the market and used in robotics to make customized drones. It has got a RPM ranging from 10,000 to 100,000 RPM. The high speed and low weight of the motors helps us to use them in drones and copters. As the name suggests, it's a brushless motor, hence there is no noise and its mechanical parts is less than that of a DC motor. But it has to be used by the help of an ESC so as to generate the required amount of current and the required type of current from generally used LiPo batteries. Hope we will see some live demonstrations of such interesting things in the following bootcamps. Next, coming to the servo motors. This motor has a wide range of application in robotics. It is a rotary actuator or a linear actuator that allows the precision control or angular or linear position control. It consists of a suitable motor coupled to a sensor for feedback of its position. This type of motors gives us a level of torque at high speed. It can be used to make the robotic arms and the robotic fingers. We can also use the servo motor for the opening of the lid in the previously said ultrasonic sensor based smart garbage bucket. Nextly, a stepper motor. A stepper motor is a brushless motor which divides the full rotation into equal number of steps. The motor's position can be commanded to move and hold at one of these without any position sensor or feedback. It can only provide us high torque at low speeds. It basically works samely as the servo motors but without embedded sensors in it. It has prominent use in robotics. It can be used in 3D printers and robotic arms. We use the stepper motors in the printers. We can also make the analog clock where there would be 60 revolutions per hour and there will be 60 steps per second per revolution. So coming to the conclusion, the crux of this session that we came to know about some sensors, their working principles, actuators along with their usage, lastly the examples of the robots and practical usage in robotics. Thank you. Next, meet you soon in the next GNX Bootcamp session.